Alright, Algebra 2. Let's get ready for our Unit 7 test. It's going to be great. You did so well on the Unit 7 quiz. You're going to love this. It's going to be a lot. Majority of the stuff that we already covered in the quiz is going to be the quiz. The test is only the systems of equations that is added onto it for the most part. Alright, to start off, I am not going to give you this, but instead I'm going to treat it as a multiple choice. So, can you identify what the vertex forms of a problem looks like? Can you connect these two dots? 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 And these. If you could, you could. You're set. Let's start solving some equations. We have vertex form. So we have something here and something here. These are going to be our h and our k, which is positive, which is negative. It depends on how you want to view it. Either you can use the formula and just understand and know that the inside stuff is going to be the opposite negative of it, and the outside stuff is a plus k and it's left alone. Or you can bring the outside stuff and bring it onto the other side, so everything just acts as inside the parentheses being negative. Leave it to you. First one, x minus 32. Well, that is already in a minus form, so that just leaves my h to be 32. My k is going to be minus 15. Y is going to be, this is y equals x, the x is being squared, so I have a negative 2 and a negative 8. Here I have an x in the front, so these things swap. This is my k and this is my h. I have a 51 as an h and a 21 as my k. Good. Moving on to our parabola. We're going to draw some lines here, but we first need to figure out where our vertex is going to be. So the easiest way I look at my vertex is saying that this is an x here. This is going to be my k. This is going to be my h. And given this a negative, I'm going to get some type of d minus. Not happy about getting a d minus, but if I know it's going to be a d minus, that will help me get an a going in. My h is going to be a negative 2, comma, negative 6. If I graph that out, go to the left 2, go down 6, I think that's 6. Yep, and I'm going to get a d. Oh, set that. For this one, we're starting off the y, and we have a negative, so I'm going to get some type of sad face. As for my vertex is going to be at, this is my h this time, this is my k this time. I'm going to have a negative 6, comma, 4. So that's going back 6, 3, 6, up 4, 4. And that's going to be a frowny face. Done and done. I'll give you credit if you can give me those drawings. Next one up, let's do some conversions from, I like to think of it like if you want to convert this and tame it into a usable form. So your generalized form is useful in certain practical applications, but for shifty it is not. So let's switch it to vertex form. I'm going to do some completing of the square. First off, I want to isolate my x's. So 10 plus 10, give myself some space. X squared minus 6x. What is my magic number that I want to add into these two spaces? And the formula I would generally go with is going to be b over 2 squared. And my b here is a 6. So that is going to be 6 divided by 2 squared, which is 9. So I have a plus 9 here and a plus 9 here. Because I did that, I know that this is going to be a perfect square. If you want to check it, it's going to be a 9 and a negative 6. What two numbers am I going to use? Negative 3 and negative 3. So x minus 3 equals y plus 19, which then, if I bring the 19 to the other side, I have x minus 3 squared minus 19. That will be my answer. Next problem up, same thing. Isolate my x's. Minus 5, y minus 5. Give myself some space. X squared minus 4x. What is my magic number I'm going to add in here? Half of 14 is 7. 7 squared is plus 49. Plus 49. Y equals 44 then. Y plus 44 equals, what's my perfect square that's going to become in here? If you want to do it, you don't have to do the step, but I want to just grill into you that it is a perfect square. We chose the 49 so that I have a great number that I can times together to get 49, and added together I get negative 14. That is negative 7 and negative 7. Negative 7 squared. Bring it over to the other side. And I have y equals minus 44 minus 44 equals, sorry, that was a square there too. X minus 7 squared minus 44. That's my answer. This one, get it into vertex form and graph it. Plus 3 plus 3 x. Notice I'm using an x, by the way, so I switched the sign. Sorry, now the one that's being squared isn't a y squared, so this is either going to be a c or a d. Give yourself some space. Y squared plus 10y. What's my magic number I'm going to add into here? 25, because half of 10 is 5. 5 squared is 25. It's 25. So over here I have x plus 28. This is going to go really off the charts. Yeah, it will go off the charts. Yeah. Equals, I don't know if I intended it to be this one. I think I wanted it to graph one of the other ones. But we're just going to do it. This is a review, so we're just going to practice it anyways. I can turn this into a perfect square. I know that this is 25 and this gave me 10. So my two numbers are going to be 5 and 5. So that's y plus 5 squared. Bring over the 28 minus 28. So x equals y plus 5 squared minus 28. I'm surprised I chose this specific number because this graph is super tiny in comparison to what I need. My vertex is going to be negative 28 comma negative 5. So, and I know that it is a positive, so I'm going to get a C plus somewhere. But this is going to be negative 28. Ooh, that's huge. So let's just, even if I were to scale this down and just make the assumption that this is scaled down, I'm going to, so you definitely start square this if I give you that goes off the chart so much. It's going to be somewhere way back here, down somewhere around here. This would be your point. This point is this right here. And then you're going to have your parabola. I will try not to have the numbers go that far off the graph. I apologize. It's all the way over here. Okay. Circles. from standard form. We already have it in the standard form. That makes things slightly easy because you're familiar with the formula. That is x minus h squared plus y minus k squared equals r squared, where your h and your k is your shifty to get the center. So here we have 9 and 3, and our radius is going to be, what is the square root of 4? 2. So this is r squared, remember. So we're going to go all the way over 9, 3, 6, 9, up 3, 3, and we're going to make a radius of 2. There's our circle. Cool, done. Here's a little bit of a tricky one. We have the center. This is already going to give us our center. Finding a circle and graph the circle and give the equation from standard form. We know what this is. We know where the center is, and we're given 1 point. So let's first start with the graphing. Let's go over 3, up 4. So our point is right here. Our center is right here. I'll even label that C. And then our point is going to be over 3, negative 1. Now the question is, what's our radius? So the radius is going to be this distance. This is P. This distance is 1, 2, 3, 4, 5. So R equals 5. With this information, can you write a form? Because you already have your H and your K. So we can take our x minus 3, which is our h, squared, plus y minus 4, which is our k, squared, equals, what does it equal? R squared. So what's our R? 5. 5 squared is 25. Keep in mind that when I ask for an R and when I ask for a R squared, you give me the opposite ones, you're going to lose a partial credit. Not a big partial credit because it's a simple mistake that even I do sometimes, but that happens. Now, don't forget to graph this. Now that you know what the radius is, at one point you can count out 5. You can count out 5. You can count out 5. You still have to graph it. This one, you also still need a graph. Given that this same setup, given the center is at -2, -2, which is going to be somewhere roughly around here, and the other point is +2, -5. You have a point right here. This is your P. Ooh, this is not a straight line. This is going to be slightly trickier. You need the distance formula. I personally don't remember the distance formula. Well, I kind of do, but I also, what helps me understand this is a triangle, a right triangle. So if I can figure out what this distance is, and I can figure out what this distance is, then I can figure out what this is based on a squared plus b squared equals c squared, which is the same as the distance formula, which is d equals the square root of x2 minus x1 plus y2 minus y1, all in the square root. You want to do this the easy way or the hard way? I'll do it the hard way first, just so that you can see it and get the practice of it. Let's plug it into the distance formula. By plugging in the distance formula, we have y2, so 2 minus 2, which is plus y2, -5, minus -2, so that's plus. Over here we have 4. Oh, these are squared, by the way. Sorry. Squared and squared. So these are squared. So this is 4 squared plus -3 squared. which then gives me 16 plus 9, which gives me 25. The square, and I have to square root all of that, which is very nice. It turns out to be 5. The other way you could do it is, I know that this distance right here, if I count this, 1, 2, 3, this gives me 3, 1, 2, 3, 4, this gives me 4. This is actually a Pascal's triangle, so when you have 3, 4, this is a 5. However you want to do the math, that distance is your radius of 5. So going with the formula and knowing that this is your h and k, let's plug it in. Go back to my blue. X plus 2 squared plus y plus 2 squared equals 25. Both of these have a radius of 5. Go figure. I just like the number 25, I guess. Okay, let's go for writing an equation of a circle as in general form into standard form. This is going to be a great completing the square. Completing the square. But you need to do it twice. 2 times. So let's organize. Put all our x's together and all our y's together. X squared plus, not plus, but minus 14x, give myself some space, plus y squared minus 12y, give myself some space, equals negative 49. Well, this half of 14 is going to give me 7. 7 squared is going to give me 49. Plus 49, add 49. That's nice. Those are going to cancel. Half of 12, negative 12 is 6. 6 squared is plus 36. Plus 36. These cancel, so I'm left with 36 on this end. And these I can turn into perfect squares. If you want to do the x, your diamond method, that's 49. Negative 14, that's going to be negative 7. Negative 7. So I have an x minus 7 squared. Over here, if I did my diamond method again, I have 36, negative 12, so that's negative 6, negative 6. That is x minus 6. So my center is going to be, oh sorry, this is y minus 6. My center is going to be 7 and 6. My radius is going to be 6. If I draw this out, this will also be outside of the scope of this graph. I chose bigger numbers than the graph I gave you. My bad. I don't regret that. 7, this is 7, and this is 6. 6 is right here. Radius of 6, so it'll touch this spot. It'll be shy of this spot. It's going to be somewhere up here. And my thing blocks it, but something like that. Yeah. Good. Oh, going back on number 11. I forgot to finish. I gotta still graph it. You have a radius of 5, so from this point, 5, 5, 5, 5, 5, 5. Yeah. Don't forget to graph the circle. Even if you did the measurements, that's great. I gotta graph the circle. Circle. All right, same as 12, 13. I would love for you to do these, but this whole time you should be doing the problem first and then watching the video. Practice and then use the video as a correction and check. Organize your x's. Y squared minus 6y, give yourself some space, equals 6. What's this going to be? Half of that is 1. 1 squared is plus 1. Plus 1. Half of Negative 6 is 3. 3 squared is plus 9. Plus 9. That gives me 16, which is going to be a nice square. And this is my perfect square of, if you want to check your diamond, that's 1. And negative 2, that is negative 1, negative 1. So x minus 1 squared plus y. What is this going to be? Diamond this one out. 9 and negative 6 times together. I'm going to get a negative 3, negative 3 minus 3 squared. That means I have an h. My x is negative, or my x is 1. My y is 3. So that is 1 and 3. My radius is 4. Draw that out. Go over 1, go up 3. And radius of 4. So here, 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 here. Good. Now we're going to do some ellipses. When I give you at the origin, and there's no minus k or minus h and minus k, then my center is going to be at 0, 0. This 81 is your a squared, so the square root of that is 9, square root of that is 4. Depending on how you want to do this, you can either graph it first and then find the coordinates, or find the coordinates first and then graph it. Please do whichever way works for you. I'm going to graph it first in this one, and I'll do the coordinates first on the next one. So I know that I'm at 0, 0. I know my center's at 0, 0. I know that I'm going to move to the right by 9 because A affects the x's, so I'm going to move to the right by 9. That is 3, 3, 3. I can't. Sorry. 3, 3, 3. That is 3, 3, 3. Then I'm going to go up by 4, 4. Going to go down by 4. This is going to be my ellipse. If I were to find these points, I can tell you that this one is 9, 0. This one's negative 9, 0. This one is 0, 4. This one is 0, negative 4. I can plug that back over in this. My x-axis is going to be 9, 0, 9, negative 9, 0, and 9, 0. And over here I have 0, 4, and 0, negative 4. Kind of mix that around a little bit. The order in which case you put this one and this one, I don't care which order it goes, but I do care what number goes here and which number goes here. Do not mix these two up. Next one up, we're still at the origin, because there's no h and there's no k being added to this, so it's 0, 0. What is 1 squared? 1 squared is 1. 49 is 7. So if I were to do this algebraically, I know that for my x vertex, I'm only going to move right and left. I am not moving up and down, so when I go right and left, I'm only going to change by the a. And my y does not move at all. So this y at 0 is going to stay exactly the same. Let me mark that in. 0, 0. The a's are going to change. So 0 minus 1 is 1. 0, 0 plus 1 is going to be, negative 1 and 1. When I go on my y, I'm only going to, when I go for my y-axis, I'm going up and down. I am not changing my x's, I'm only changing my y's. So when I go up and down, I know that this number never changes, the x, so the x can be left in. Only my y's are going to change. So 0 plus minus 7 is going to be negative 7. 0 plus 7 is going to be 7. If I plot that out, we're at 0. So the right one, and then up 7, down 7. It's a very thin, tall. That was not a shape that I want. Well, I can not draw this narrow of an ellipse, or at least Schoology does not acknowledge my writing for that. Cool. Can we take a graph and convert it into an equation? This is what you gotta do for your art project. So let's see what you got. These are symmetrical right at the origin, so I know that this is going to match over to this side. In that case, I have the 0, 3. Oh, go back. Sorry. This is 0, 3 here, and this is 6, 0. So the matching one is going to be the negative 6, 0, and this is 0, negative 3. Because that's over on this point is negative 6, 0. And over this point is going to be 0, negative 3. What is my a squared? My a squared is the distance here. That is a. And now I need a square it, so that's going to be 36. 6 squared is 36. What is my b? My b is this point, and now b squared. So I have 3 squared is 9. Plug that into my equation of the ellipse. X squared over 36 plus y squared over 9 equals 1. Just 1. That one should be good. Let's do some shifty ellipse now. Remember, the technical term is the translations of a graph. You want to translate it, you translate it. I call it shifty. A is going to be 5. A is going to be 5. B is going to be 3. You see where I got it from? That 9 square root is a 3. What is my C? My center. A lot of people kept putting the A and B here. That is not the case. What goes in here is your H and your K. Where's my H and my K coming from? It's the shifty that takes place inside the parentheses with the X and the Y. It comes from here. So our equation goes X minus H. So I have negative 2, and it's Y minus K, which already we have a Y minus 4, so that makes it a 4. Let's do this algebraically first. So I know that when I move from my x-axis, I'm going left to right. Left and right means this number is going to change, but this number stays exactly the same. So I can just add that in because I know that's number not going to change when I go left to right. As I go left and right, I have to add on the a. So I have negative 2 minus 5, which gives me negative 7, and negative 2 plus 5, which gives me 3. A lot of people made the mistake of doing 5 minus 2 and 5 plus 2. That's wrong. It's not a minus this x. It's this x minus and plus this 5. The order of operations really matter here. Now when we're going for the y-axis, I'm going up and down. Up and down means that I change my y's, but I do not change my x's. So this x stays the same. This one changes. The y changes. So I can just write down my negative 2's on both the x's because they're not going to change. But I know my 4 is going to be a minus 3, which gives me 1. And my 4 plus 3 gives me a 7. Those are my points. I know where my center is. Go back 2, go up 4. This area, I'm going to, my y is going to go negative 7, 3. So this is negative 7, and then 4 to 3 here, and I'm going to go down to negative 2, going to 1, and then up to 7. So I'm at 4. So I just need 3 more. Here we go. I can connect those dots. That's a good ellipse. Thank you, Notability, for saying that I actually drew an ellipse on that one. Okay, let's do 18 the geographic way, because I think some people have an easier time graphing it first and then plugging it into and seeing the points. You do you. I do that way, but I would like for you to be able to do the algebraic way. But in the end, whatever works for you. All right. My A. What's my A going to be? What's my B going to be? 2 and 4. What is my center going to be? My center is these guys. So I'm going to have a 3 and a 1. So let's draw my 3 and my 1. Go over 3, up 1. Okay. I have my A. I'm moving over to the right by 2 and my left by 2. So right by 2, my left by 2. Going up from my center, I'm going to go up 4 and down 4. So up 4 and down 4. And I can graph that. That's done. Now, where are those points? That's 3, 5. Over here is 3, negative 3. And over here is, what's that, 5? 5, 1. Right? Yeah, 5, 1. And over here is 1, 1, 1, 1. So, write that out. 1, 1, 5, 1. 3, 5, 3, negative 3. Good. We can do it the same way you would, if you even, you can even double check with our algebra. This would be 3 minus 2. This is 3 plus 2. Over here is 1 plus 4. This is 1 minus 4. Yeah, all the numbers match up. Looks beautiful. All right, let's give out some equations. We have Mickey Mouse here. Mr. Dang drew you a Mickey Mouse. Let's label some of the points that we want to find. We want to look for the center of things. So the center of this is right in the middle of the nose. This is the center of the whole face, which is going to be 0, 7. The center of those ears are going to be 6, 14. And on the back side of it, it's negative 6, 14. I want to know what the eyes, I want to know the ellipse eyes. So the center of that is negative 2, 10. And positive 2, 10. For the most part, that's all the points I really need to know. Since we're only doing with ellipses, and yeah, that's fine. All right, the face. We know that the head is a circle, and it has a radius of 7, r equals 7. So that just becomes, all right, shifty, so we went x minus 0 squared plus y minus 7 squared equals 49, because 7 squared. Done. If you want to clean this up and turn this into x squared plus y minus 7 squared equals 49, because you don't technically need to have the 0 here, you can. I'll give you credit for both. Ears. Your ears, the left ear. This is the left ear. Left ear is x plus 6 squared plus y minus 14 equals, what's the radius here? This radius is 3 squared. Or, sorry, it's r is just 3. So this is going to be 9 squared. You get where I took the numbers. I took the numbers. This number went to here. This number went to here. Okay. And then this number went to here. The right ear. We're going with the right ear. What is the radius that I have? It's also 3. It's also 3. So it's going to be x minus 6 here, because it's shifted to the right, plus y minus 14. We're still shifting up. Squared equals 9. Right ear and left ear are very, very similar. It's just the difference between this negative and this positive. Shifted to the left, shifted to the right. eyeballs. We're going to get ellipses. So let's check what our distance are. The distance going up and down, basically the b is going to be 2. The is, oh, it's not a perfectly clean number. 1.5. I tried to make everything so clean and perfect, but yeah, we do our best. So first, let's get the shifty part first. We know it's going to be divided over something, but let's just figure out what we can and what we know. Our x is going to be plus 2. Our y is going to be minus 10. Shifted back 2 goes up 10, okay? What is our a squared? It is 1.5 squared. I'm not giving you a calculator on this test, so I don't expect you to know what you could do. If the 1.5 squared is 2.25. How do I know that? It was used a lot this week for the scavenger hunt. But if you left it as 1.5 squared, that's fine too. 2 squared is 4. If you put 2 squared and not 4, that's arguably okay, but you know what 2 squared is. So that one is done. The right eye, similar A and B, everything is going to be the same except for the shifting of the x. So the x is going to be minus 2 squared over 1.5 squared plus y minus 10 squared over 4 equals 1. The nose, that one is just going to be x minus 0 squared plus y minus 7 squared equals, what's the radius of the nose? Just 1. 1. If you notice, the face and the nose equation are super similar. The only difference is this 49 versus this 1. And if you think about it, that makes sense. This is a small circle in a giant circle. The only difference is this radius is a small radius comparison to the larger radius that makes the big circle. These are how the formulas work. Hopefully they relate. Here's a bonus challenge for you to do. I wanted you to make a smiley face. You can make your smiley face however you want. I'm just going to be simple and choose something like this. So I want this point, and I probably want this point. You need at least 2 points if you have the vertex in vertex form to solve this equation. This is where you need to figure out what A is, and A becomes important. So we'll do this. I want this point and this point. This point is 0, 3, and this point is 2, 5. They're going to connect and make a smiley face. Creepy looking smiley face, but not perfect. So your parabola form is going to be xy equals x minus h squared plus, okay, sorry, there was an a in front, and you do need that a in this case. So keep that a, because a is the key thing that we're trying to solve. We know what the vertex is. So we already have our h and our k. This is our h and k. Our h and k is right here. This 2, 3, or 0, 0, 3 right here is the bottom tip of the smile. So we can at least plug that into our equation. We have y equals a x minus 0 squared plus 3. Let's simplify that. Y equals a x squared plus 3. We have to now plug in another point, which, yay, we chose an easy thing to plug in. We can plug that into the x and to the y. That's going to give us 5. 5 equals a times 2 squared plus 3. Let's minus the 3 on both sides and just square this. So we're going to have 2 equals a times 4. divide by 4, divide by 4. You have a equals 1/2. Yeah, I have what the a is. Now plug this back into this equation. I guess you can plug back into this equation because it's simplified. Either one will be fine. You're going to have y equals 1/2. That was a. Times x squared plus 3. That is your smiley face. This parabola equation will give me this parabola right here. To be very specific, I also set the domain. I realize, and that would say, let's just go with the y. So I want y be in between 3 and 5. So 3 is greater than or equal to y, which is greater than or equal to 5. So this is the whole answer I want. Give me the restrictions. Because otherwise, if you didn't give me this restriction, this probably goes across his whole face. It's very Joker-esque and creepy. We just want a simple smile, small smile. All right, last page. We're going to do some systems of equations. Identify the shape and then solve either by substitution or elimination. Let's identify the shape is the easier part. What's being squared? X and y are being squared? Cool, we either have a circle or an ellipse. Are the coefficients the same? No, then we have an ellipse. Over here, we don't even have a y, or we have no y, we just have an x, so we have a straight line. We just have a line. Technically, you can even solve this in a third way if you really were really good about this. There is the algebraic way, which let's just do the algebra way because that's what this lesson is about. This is great setup for a substitution. You can take this and just shove it into this right here, which is very simple because 0 squared is just going to give you 0 plus y squared over 81 equals 1. This disappears, times everything by 81. So I'm going to have that cancels. Let's just do 81 over here. That cancels here, so I have this, and that equals 81. Square root gives me positive negative 9. Y equals positive negative 9. So when x is 0, you have y equals positive negative 9. Write that as a coordinate, and I get 0, negative 9, 0, positive 9. That is what I want. You could solve this a third way by just graphing it, given that you know your shifties decently well. I would have an ellipse centered at the origin, which then has an a is 1. It's this a equals 1, b equals 9. So something super tall up here, down right here, and I have this circle. And I know that's going to be 0, 9, and 0, oh sorry, it's positive 9. 9 and 0, negative 9. And I want to know the line when it's at the line. When x equals 0. Those points are going to be right here and here. Same thing. If you drew this and gave me this and didn't give me the algebra, I would give you full credit. You can prove it by graphing, but you got to be very specific and good with your graphing. This is kind of easier. Substituting numbers. All right, next question. What shape is this? Is y being squared? No. Is x being squared? Yes. So we have a parabola. I don't really care for you to tell me what type of parabola, but if you want to, you can. It's going to be a happy face. Sure. I just want to make sure you identify the shape. It's the squared. The next one, y equals x minus 2. Is y being squared? No. Is x being squared? No. Got a line. It's just a straight line. In this case, we can also do some decent substitution. So let's just plug in from this one into here. And we have x minus 2 equals y 2 5x plus 6. Let's bring everything to one side. So minus x plus 2. This side becomes 0. So it becomes x squared minus 6x plus 8. Right? That looks right. Let's go back to our diamond method. Times gives you 8 minus 6. So with two numbers added together gives you 8. Gives you 6. We can... I was going to have... So we can do a negative, negative. And so we'll have 4 and 2. Right? Because when you 4 and 2... Negative 2 times negative 4 gives you positive 8. Add together gets negative 6. Wonderful. Plug that in. X minus 2, x minus 4, x equals 2, 4. Are we done? No, we got to plug these things into our equation. So we can take these two numbers and plug it into... Nah, I think the easiest... Which one's easier? The top one or the bottom one? The bottom one's a line. That's easy. So let's see what it is at 2. Which then minus 2, y gives you 0. So at 2, it is 0. That's one answer. And then y equals, when x is 4, minus 2. So y equals 2. That gives me 4 on the 2. This is your answer. Does it make sense where those came from? I took this number, I plugged it into this 2 of this. So first, this is what these equations are. I plugged this one into here. Doing the math, you get this right here. And then I plug this, and I plug this. And that's what you get here. On the same token, I take this, plug it into this, do the math. You get this one. So this one goes here, and this goes to here. You're solving to get a few x's or y's, and then you plug it back into the equation so that you can get the other variable. Next shape. What do we have here? Is y being squared? No, it has a coefficient, but that doesn't really matter at this early point. Is x being squared? Yes, that gives you a parabola. Also a smiley face. This down here is also another parabola. Also a smiley face. This one gets slightly trickier because if I were to substitute, that would be painful. That would be really, really painful, and I don't want to do that. I don't want. You can't make me. You could, but what I can also see is this is 1/3 of the y. This is 1/3 of the x squares. This is not really... let's just focus on the two that are... This is 1/3, and this is 1/3 of the ones above it. So if we times everything by -3... Sorry, -3. If I multiply everything down here by -3, I will get rid of these ones. So let's do that. So times all of this by -3. So I'm going to get -3y equals negative x squared plus x. Sorry, 3x. Go back. This is negative minus 3x minus 9. Pull it down the... Apologize for my cough. Take the original equation that we had from the top. 3y equals 3x squared plus 2y plus 2. Let's do the math. These cancels out. These cancels out. Leaving here in x. Negative x. This is 0. Negative x minus 7. So because yeah, 7. Then I'm gonna have a x equals -7. Am I done? No, I gotta plug this back into my equation. So plugging it into the equation, I'm gonna have y, 7. Where did my 7 go? 7. So let's plug this back into the equation. Top one or bottom one? Bottom one has less multiplication of 3, so let's just choose the bottom one. So y equals -7 squared plus -7 plus 3. -7 squared is 49 minus 7 plus 3, which is the easiest way to do this. It doesn't really matter. Adding like terms, 52 minus 7 goes down to 45. Yeah, y equals 45. So my coordinate pair is going to be -7, 45. Right. All good. And yes. All right, next one up. This looks like a lot, but quite frankly, a lot of them gets canceled if you just minus it. So minus, turn that into a plus, turn that into a plus, minus. Cancels. Those don't cancel, so that's 12x. Cancels. Oh, that even cancels. Equals 12. Divided by 12, divided by 12. I get x equals 1. All right, take that, plug it in. Don't know which one to plug into. I don't think it matters, so let's just go into let's go to the bottom one, because the bottom one has less variables, or less a smaller constant. So that is x squared, so that's 1 squared plus y squared minus 6x minus 2y plus 6 equals 0. And that becomes a -6, a 1, y squared, -6 minus 2y plus 6 equals. These actually cancel. So I am left with y squared. I'm going to reorganize this so that it looks neater. Y plus 1 equals 0. Oh, that's nice. That's a perfect square. You want to do your diamond method. That is a 1. And a -2, that's -1, -1. Minus 1 equals 0. So y equals 1. So my answer here is going to be 1, 1, 1. It's just one location. 1, 1, 1. Come on. What were the shapes? I forgot to write that down. The coefficients. What are being squared? X and y. Cool. That's a parabola or a. What's is my leading coefficients? What's the coefficient for my x and y? 1 and 1. They're all 1, so that's going to be a circle. So this probably ends up to being 2 circles that like kind of just kiss each other. They don't cross the line, but yeah. Last problem. We're going to see. I personally like to do a lot of elimination, and this seems like a nice perfect elimination if I were to say so myself. This is going to give me an x squared. These cancels. Gives me a 4. That gives me 4. Square root x equals positive -2. Positive -2. Let's plug that back into. We can plug into the bottom one. Let's start with the -2 first. So -2 squared minus, oh no, so plus y squared equals 13. That gives me 4 plus 1. Minus 4 minus, oh sorry, 13 minus 4 y squared equals 9. Oh, that's nice. Square root y equals positive negative 9. So for a negative, when I have a negative 2, I get a negative 9 and a positive 9. So I get these two locations. And then when I have a positive 2 squared plus y squared equals 13, this is going to be the exact same formula because positive and negative being squared doesn't matter. 13 minus 4 y squared equals 9. Square root. That's y equals, oh, this is 3. Oh, gotta go back. I wrote something totally wrong. Silly me. Square root of 9 is 3, not 9. Positive 9, so that's negative 3 and a positive 3. And when I have a 2, I have a negative 3 and a positive 3. These are my 4 possible solutions. Nice. That should be done. This is some type of ellipse, circle and an ellipse type of thing. So these are both being squared, but they have different coefficients, so that's an ellipse. And this is a circle because their coefficients are the same. Done and done. I hope this all makes sense. I plugged these in. If I want to just reiterate the point, I took this one as a negative 2, I plugged it into here. As a positive 2, I went into here. Gives me this one and this one. So when it's negative, I get these 2 points. When it's positive, I get these points. In the end, these are all the 4 coordinates I get. Good luck. You got this.